This question, which of the following is not a favorable condition for occurrence of thunderstorm? See, जैसे ये thunderstorm का question आ रहा है, at the same time you have to remember the video that I've shown, video of thunderstorm. What all things do we remember? First, there has to be a moisture ground, so near sea, any ground which is supplying moisture. There has to be warm air and there has to be cold air. The warm air will go up, updraft. Cold air along with rain will come down, downdraft. So when updraft and downdraft happens, that is the point of, that is why thunderstorm occurs. So updraft, downdraft is necessary for thunderstorm. This is clear. Now let's do the question. What's the question? Conditional and convective instability. Now instability, what does instability means? In inversion of temperature, we have read that instability means vertical movement of air, and another term we have read, calm, means no horizontal movement. So if the air is calm and stable, it means there is no horizontal movement, there is no vertical movement, if you remember. So let's go to notes. Let's go to temperature inversion. Chapter number 9 it was. You see here, calm means no wind, stable air means no vertical movement of air. Okay, you need to know all the words absolutely clearly. You have to distinguish between those words. So instability, stability, calm, not calm. Do you get this meaning? So now, conditional and convective instability, that is movement of air upwards. This happens in thunderstorm. Yes, it happens. Now, adequate supply of moisture in the lower level of atmosphere. Adequate supply, absolutely yes. Advection. What does advection means? Horizontal movement of air is known as advection. Okay. Advection of cold air in the lower troposphere and warm moist air in the upper troposphere. No. Cold in lower, no. Warm in lower, and that is not advection. In thunderstorm, convection happens. That is why cumulonimbus clouds occur, if you remember the video. So this is wrong. A synoptic situation of low level convergence and upper level divergence. What does this line means? So now there is sea, moisture, updraft, updraft, downdraft, it will diverge here, downdraft, divergence, downdraft, like it happens in cyclone. If you remember cyclone, where is cyclone? You see this? There is updraft and then updraft and then downdraft, updraft, downdraft, and then again coming in. So it goes up, then it will travel some distance, and then it will come down, and then again it will converge at low pressure. So that is the meaning of the line. Where is the line? The synoptic situation of low level convergence and upper level divergence. Low level convergence from here and upper level divergence from here. Okay, so C is the answer. Again, good question, very good question. Next. Now thunderstorm you have to read here. कहाँ गया? थंडरस्टॉर्म ढूंढ रहे ना हम. Here. You see, pause and read this. Condition of thunderstorm. This is all you should remember, and the video you must remember. Now, next question. 65. Which of the following statement about the equatorial region is acha? This is 12th chapter question, so we'll skipping it for now. Again, 12th chapter, not now. 12th chapter, not now. This question, 68. Which of the following layers of the atmosphere has the highest concentration of ions? Maximum number of ions. Do pause the video and then solve it yourself and then explain and then see the explanation. So ions, most of the ions are found in thermosphere, that is ionosphere. Ionosphere. Ionosphere is within thermosphere, if you remember the diagram. So again, As you are reading these questions, you must recall the diagram. If you're not recalling the diagram, go and see and then recall the diagram. This should be your first instance. The brain should operate in that fashion. See the keyword and see these keywords are triggering which kind of memory. And the memory must be your diagram. Then you have understood the concept. You see, ionosphere within thermosphere. Okay, now what does ionosphere do? Let's go to ionosphere and read ionosphere. This is ionosphere. Layer within thermosphere, okay? Located between 80 km and 400 km above mesopause. Composition: electrically charged ions, because particles in ionosphere interact with UV and UV breaks these particles, and hence free ions are accumulated in thermosphere, which is known as ionosphere. Function: reflect radio wave back to earth, increasing temperature as we go up. This is the temperature gradient in thermosphere, in ionosphere or thermosphere. Application: radio communication, International Space Station, auroras, and Kármán line, a boundary between Earth's atmosphere and outer space, that is around 100 km. Okay, so these are the features of ionosphere. Do pause and read it yourself and then move ahead. Climatology. Okay, so answer is C. Ozone layer depletion is a major phenomena. In where is ozone layer found? In stratosphere. Hence, ozone layer is in stratosphere depletion. Now, how does ozone layer deplete? You see, ozone is made up of O3, three ions of oxygen. This is ozone. Now, let's just suppose CFC is a ozone depleting substance. CFC, C, chloro, fluoro, carbon. When this react with UV, this chlorine gets separated, and this chlorine is free floating. Now this chlorine get attached to ozone because chlorine has good affinity with ozone, and hence this O, one of the O from O3 is taken away by chlorine. Now the resultant is ONO, and this is ClO. Ozone has depleted. So that is why CFC is depleting ozone layers. Okay? Cl is interacting with O3, and this is converting it into O2 plus ClO. Hence ozone depletion. आगे देखते हैं ये हो क्या. Now tropical cyclone. Pause and do it yourself. Willy Willy 3. Typhoon East Asia. Hurricanes USA. Cyclone India. 4 1 2 3. 4 1 2 3 B. Next question. Which of the following factors is not connected with planetary wind system? Planetary wind system, that is, we are talking about this phase. Northeast trade winds, southeast trade winds, westerlies, westerlies, easterlies, easterlies. We are talking about these things. Okay. Now let's see. Not connected, mark not, and then find out the true statement. Do not go for not, go for which is true. So what are the factors for planetary wind system? Latitudinal variation of atmospheric heat. Of course, when there is a variation in heat, high pressure and low pressure will be created, and hence movement of the wind. Correct. Emergence of pressure belt. Of course, these pressure belt, high pressure, low pressure. Revolution of earth. Through revolution of earth, these special belt moves up and down. As the sun moves, high pressure and low pressure also move. So these belts also move. This can be true. Migration of pressure belt due to apparent. This is absolutely true, absolutely true, absolutely true. The least favorable option is C. Otherwise, if all of the above were an option, then this would have been correct, or none would have been the answer, and none of them are incorrect. But here, if you have to choose, then choose C. This is the weakest link. Okay. Now next. Doldrum. Doldrum is low pressure area around equator where the prevailing winds are calm. Okay. Are doldrums low pressure area? Of course. Again, same. Here, low pressure area, this calm winds because wind is converging and then going up. So here, no wind, calm area. Okay. Now above it, subtropical high. Here, wind is coming down and diverging. Again, here, no wind. Again, calm. So this is horseshoe latitude, or yeah, horse latitude, and this is doldrum. Both have calm air. One due to high pressure, one due to low pressure. Okay. Let's see the diagram now. You see this? This is doldrum, low pressure area, very calm, calm. This is high pressure area, horseshoe latitude, calm, very calm, calm, calm. Okay. Now let's go. So this is over. This is over. Now let's solve this question. Doldrum is a low pressure area. Of course, it is a low pressure around equator. Yes, where prevailing winds are calm. Correct. Low pressure is caused by heat at the equator, which makes the air rise and travel both in northern and southern side. So this is what happens. This goes heat goes up. Some of it will go in southern hemisphere. Some of it will come in northern hemisphere. So it is going in both the direction. Here, again, same story. Here and here. Okay. So now let's come here, here. So this is also correct. This is also correct. Because satisfying. Is it the correct explanation? Low pressure. Theme is low pressure. And here they are giving the reason for low pressure. If this theme and this theme are related to each other, then the reasoning is correct. It has to be absolutely different from this. Then only you would say the reason is not correct. So if both the themes are repeating, then generally explanation is also correct. So A is the answer. Next question. 73. Roaring 40s. Okay. A strong westerly. Are they westerly? Yes. Found in southern hemisphere. Are they found in southern hemisphere? Yes. Generally 40 to 50. Absolutely yes. Roaring 40s from 40 degrees, furious 50s, and screaming 60s. Okay. Let's come here. Now this is correct. The strong east to west air current. East to west air current. Okay. So we are talking about east to west air current. There are only two east to west air currents. East to west trade winds. East to west. Okay. Easterlies. East to west. Okay. So these two they are talking about. Okay. Are caused by combination of air being displaced from equator east to west. Currents are moving from equator towards pole. No. East to west currents are moving from tropics to equator or poles to subpolar region. So this is absolutely wrong. This is wrong. One is correct. Answer would be C. One correct, two false. Next. The innermost region of hurricane is known as hurricane eye. Innermost region of the hurricane is a hurricane eye. Absolutely correct. Where? Now, they are talking about eye wall. I mean to say eye of the cyclone. Temperature is highest. Yes, temperature is highest. Maximum low pressure. Yeah. And pressure is lowest. Absolutely correct. Why is this happening? Same story. Latent heat of condensation. Heat is added here. Heat goes in, temperature become high and pressure become low. Descending of air. Okay. So again A. Next. Hurricanes rarely move within 5 degree of equator. We have seen in South America. Here no tropical cyclone, here no tropical cyclone, despite the fact that low pressure is formed. Why? Because low pressure here is formed near equator and Coriolis force is 0. So Coriolis force is weakest here A. Again, that diagram. Here. Nothing. No cyclone here. No cyclone here. Both the places, no cyclone. Why? Because low pressure, this low pressure is near equator. Again, here, low pressure, very much near equator. Read this, read these lines. Pause and read. Next. 76. Whenever a tropical cyclone moves to land, much of its severity is reduced. This is due to, you see, tropical cyclone forms because of moisture plus low pressure. These are prerequisite of a tropical cyclone. Its source of moisture is cut off, correct. The friction over land kills tropical cyclone. You see, tropical cyclone has a lot of power. It has a lot of power. So just frictional force cannot kill a tropical cyclone. As you remember, that a frictional force operates only 1 to 3 kilometer above the surface. A tropical cyclone is formed at a height of more than this, like 3 kilometers. It is formed above 3 till troposphere. So 3 km to 14, 13 km. So frictional force can reduce the speed but cannot kill it. Only moisture, no supply of moisture can kill. That is why when tropical cyclone encounters land, and when the eye of the cyclone is over land, you see, this is eye, this is cyclone, this is cyclone. So if land is here, rainfall, cyclone will occur. Now, option 2, this land, I will be here, no wind here, and here cyclone. Now I, third example, I will, this is land, I will be here, cyclone is over. When I is completely on the land and there's no supply of what you say moisture, then the cyclone will be killed. So this is it. Over. Now next. So answer would be A. Next. Which of the following statement related to cyclone is not correct? Not correct, always find correct. It is wind circulation system with low pressure at center, correct. It brings about sudden change in weather, correct. The wind movement towards the low center of the cyclone is clockwise, incorrect. It is known as hurricane in West Indies, yes. Now let's go to ANC. If you remember ANC, African National Congress. A and C. A here is known as anticyclone. N is known as north hemisphere. C is known as clockwise. Okay. Now here C is known as cyclone, north hemisphere, and this is anti-clockwise. Anti-clockwise. Okay. Do pause this, do write it on a paper and then open this up. Otherwise, it will be difficult for you to recall this. You see how? Let's imagine in northern hemisphere we are looking at low pressure. Wind is coming from here. In northern hemisphere, wind will move this way. It is moving this way. But due to low pressure, the wind will converge to low pressure. This is anti-clockwise movement. Okay. Now high pressure. The direction of the cyclone is represented from the behavior of the wind around the pressure. So in high pressure, you remember that anticyclone starts with jet stream divergence. So here, high pressure. From high pressure, your temperate cyclone starts. So from high pressure, wind will go out. and this is your clockwise direction. Okay. Now next, 78. Which of the following is the most powerful in determining movement of wind, including its velocity? Okay. So this is again simple. There are four forces, especially three forces are more important than gravity. One is your pressure gradient force for movement of wind. If there is no pressure difference, there will be no movement of wind. That is why we call pressure gradient force as the originator of wind. Originator of wind. This is pressure gradient force. Second force is Coriolis. That is deflection of wind. Third is frictional force, and fourth is your gravity, gravitational force. This is very minuscule. These three impact the wind direction and velocity the most. Okay. So which of the following is most powerful? Gravity not most powerful, not most. Pressure gradient is most powerful. Okay, among all. If in place of this there would have been Coriolis, then also answer would have been pressure gradient force. Okay, so D is the answer. Next, again wind. Local wind is not characterized by hot and dry. We are talking about cold winds. You must not remember this. It would be difficult for you to remember this hot and cold wind. Just see the location of this. Sirocco, Africa, warm. Khamsin, Africa, warm. Chinook, snow eater, must be warm. This is cold. Mistral. So if you remember that diagram, in Europe, that is Fohn, Levant, Mistral, and Bora. So this is Bora, this is Mistral, this is Levant, and this is Fohn. So this is warm, rest cold, cold, cold. Okay, let's see the diagram. You see this? Levant cold, Mistral cold, Bora cold. Pause and see it. Fohn warm, Sirocco, Ghibli, Khamsin. They are same winds. Sirocco, they call it in Tunisia, Algeria, Morocco. Ghibli is same wind as Ghibli in your Libya, and Khamsin in Egypt. Okay. Now next. B. Relative humidity. Easy. There are three terms in humidity. First, you have to remember this, understand this. What is humidity? What is absolute humidity? And third is relative humidity. These three terms. Humidity means water vapor. If we say the weather today is humid, you mean that there is water vapor in the wind. That is it. That is what humidity means. Water vapor in the wind is humidity. Okay. Now absolute humidity means, now if I ask you that how much amount of water vapor, if you say that there is water vapor in the air, we would call it humidity. If I ask you how much water vapor is there in the air today, so that is another absolute humidity. Absolute number you must give, and that number is gram per meter cube. This is a unit of absolute humidity. Okay. Now relative humidity. Now if I say that a air parcel capacity to hold water is 10 liters, and today it has 5 liters. So relative humidity would be 50%. So relative humidity is in percentage, that is 50%. Total capacity and current capacity. So current capacity upon total capacity into 100. This is how we calculate relative humidity, 50%. Okay, so relative humidity is in percentage, absolute humidity is in gram per meter cube, and humidity is water vapor present in air. Now next, now let's just see what is this. Relative humidity increases with, okay, let's go ahead. Let's understand condensation, then you will be able to understand this. Condensation. You see, condensation simply means vapor into liquid. Okay. Let's just say air parcel, 10-liter capacity. It has 8-liter capacity full, that is, its absolute humidity is 8 liters. Now it moves over a ocean and 4 liters of water is added to this air parcel. So its capacity is 10 and added is 4, that is 12 liter. So now 2 liter of rain will occur in that area. So this is what condensation means. Condensation means the removal of water from cloud or air so that it reaches the removal of water from the cloud or air above its water carrying capacity. So if 10 is the limit of this air parcel, so it will remove whatever extra air is there, extra water vapor. So removal of extra water vapor is known as condensation. Okay, now let's go. Now there are 4 scenarios. First scenario, try to do it yourself, I'm writing. When temperature increases, what will happen to condensation? When pressure increases, what will happen to condensation? When humidity increases, what will happen to condensation? When wind speed increases, what will happen to condensation? Pause and try to write what will happen to condensation. Temperature, pressure, humidity, let's just suppose volume. So let's just see when temperature is increasing. So temperature is increasing, the air parcel containing 10 liters. Now this air parcel will expand. It can contain 15 liters of air liquid. What does this mean? Now the carrying capacity of the air parcel is more, hence less rainfall. Because to reach the limit of 15 liters, more water has to be added, hence condensation will come down. So if temperature increases, condensation comes down. Okay, now volume, same story. If air parcel is this much and its volume increases, it can contain more water vapor, hence condensation will come down. Pressure, if pressure increases, this is the air parcel, 10 liters, pressure increasing, it will reduce, size will reduce, 5 liters. Hence if we add 3 more liters to this rainfall, here if it was at 5, now here if we add 3 liters, it will be at 8, no rainfall. Hence condensation increased as pressure increased. Pressure increased, condensation increased because volume decreased. Humidity increasing, same story, 10 liters has 5 liter. Humidity increase, more water vapor is added, that is, let's just suppose 3 liter here added. Again humidity increase, let's just suppose 5 liters added. So capacity was 8 plus 5, 13 liters, which means 3 liters of rain. So as humidity increases, as you add water vapor, the condensation increase. Okay, so temperature, pressure, volume, temperature, pressure, volume and humidity, how condensation is behaving. Now let's go to question. Relative humidity increases, which means 5 liters, 10 liters. Relative humidity increase, this is 8. Increases, no, So this is 5 is to 10, 50%. Now let's just suppose relative humidity has increased. It has gone to 8 and 10 liters. This is 80%. Relative humidity increased. Okay. With increasing temperature has increased. That is why relative humidity has increased. Temperature up, expansion of air, more carrying capacity. No, wrong. When temperature up, more expansion of air, hence relative humidity must decrease. That is 10 liters of carrying capacity, temperature is up. Now its carrying capacity will be more. 5 liters, this is 20 liters. So relative humidity must decrease with increasing temperature. And so it would be. Next, the process by which heat is transmitted from sun to earth, radiation. Conduction, layer by layer, heat is transported. Convection, the hot air parcel will go up and will cool down and then come down. So this is convection, and radiation is without any medium. That's it. Over.